Okay, well, this talk isn't about astronomy, unusually, but it will include several astronomical examples. It's about science overall and the scientific method, but especially with regard to one particular topic. I'll put the title, It's Only a Theory, in quotes, because it is, of course, a very silly but alarmingly common misconception. Of all the great many theories in science, one in particular, far more than any other, causes vast degrees of animosity and emotive argument between its supporters and its opponents. Yet the theory in question is, within the field of science, considered as indisputable, as close to being proven fact as any theory possibly can be. There's no serious scientist in the world who disputes it, but there are many people who do for reasons that have nothing to do with science. I refer, of course, to the theory of evolution by natural selection. Those who dispute it do so for religious reasons, mainly young Earth creationists who insist, despite the overwhelming evidence to the contrary, that the creation happened as described in the Bible, with God creating the world as it is today, with humans and all the animals we know already in it just a few thousand years ago. Anyone who denies evolution is not only denying a single theory, they are in effect denying almost the whole of modern science, as it's supported by evidence from almost every branch of science. A Christian friend of mine has pointed out that all Christians, and Jews and Muslims, are creationists in the sense of believing that the universe was created by God. But the word is usually applied to young Earth creationists, those who deny the existence of evolution and the age of the Earth and insist that everything in the Bible is literally true. And that's the sense in which I'm using the word here. Let me also clarify something at this point to avoid offending anybody. I'm not saying that anyone who's a Christian or anyone who believes in God is a loony, but I am saying that anyone who disputes the indisputable and believes in things that are completely and provably false, such as that the Earth is 6,000 years old, is a loony. Such people are fond of dismissing evolution by claiming that it's only a theory, as if that somehow means it's no more valid than their own beliefs. I once had a debate with a chap who was ranting in the street, inflicting his own religious beliefs on passers-by, whether they wanted to listen or not. He said that he doesn't believe in evolution and insisted belligerently that it's not called Darwin's fact of evolution, it's called Darwin's theory of evolution. What he and others like him are actually doing is displaying their own complete lack of comprehension of how science works and what the word theory actually means. Or in some cases, they might be deliberately ignoring the true meaning and preying on their audience's lack of comprehension. In science, there's no such expression or concept as only a theory, because there's nothing better than a theory. A theory is, in fact, the highest status that any scientific idea or model can attain. There's no only about it. I'll now explain why. So what is a theory? In everyday language, the word theory is often used pretty loosely to mean an idea, a hunch, or a guess, such as in TV crime dramas when a detective has a theory about who committed the murder and why. But in science, it means something much more precise. The Oxford English Dictionary gives several definitions of the word, one of which more or less corresponds to the common usage I just described. But the one listed first, which is the meaning used in science, is a bit of a mouthful. A scheme or system of ideas or statements held as an explanation or account of a group of facts or phenomena, a hypothesis that has been confirmed or established by observation or experiment, and is propounded or accepted as something as accounting for the known facts, a statement of what are held to be the general laws, principles, or causes of something known or observed. Wow. To put it a little more simply, I would personally define a theory as follows. A model or explanation of an observed phenomenon or group of phenomena which is strongly supported by the available evidence and is generally regarded as the correct explanation until or unless evidence is found to the contrary. That last phrase is vitally important. Unlike religious beliefs, which are based on dogma and the concept of sacred truths which must never be challenged, a scientific theory is accepted as being correct only so long as it continues to be supported by the evidence. If evidence is ever found that can't be explained by the theory, then the theory, or some detail of it, is proved wrong and must be modified to account for that evidence. Those creationists who claim that evolution is only a theory often also claim that it hasn't been proved. This again proves their ignorance of how science works. They apparently think a theory becomes a fact or a law when it's proved. But this is not the case. Theories and laws are two completely different things. A theory doesn't become a law when it's proved. In fact, strictly speaking, a theory can never be proved, as I'll explain shortly. In science, a law is a mathematical description of a phenomenon deduced by observation or experiment. A theory is an attempt to explain a phenomenon. To illustrate the difference, let's consider the phenomenon of gravity. Newton's law of gravity, or more correctly, the law of universal gravitation, as formulated by Sir Isaac in 1687, states as follows. Every object attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. It can be expressed mathematically by an equation where m1 and m2 are the masses, r is the distance apart, and g is called the universal constant of gravitation. According to legend, the concept first occurred to Newton when he saw an apple fall from a tree and realized that something must cause it to fall. He deduced the law by studying the observed motions of the planets. The value of the constant of proportionality, denoted by g, was calculated by experiments performed by later physicists. Its numerical value depends on the units we use for mass, distance, and force. In standard SI units, it's 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. So this law tells us that all objects in the universe attract each other with some kind of force and tells us how this force behaves. It gives us a mathematical formula with which we can calculate the attractive force between any two objects if we know their masses and the distance apart. But it doesn't tell us what gravity is. Newton made no attempt to explain what causes masses to attract each other with this mysterious force. He couldn't possibly have done so because the explanation depends on concepts that weren't thought of till more than 2 centuries later. An explanation of gravity had to wait for the genius of Einstein, who published his general theory of relativity in 1915. He realized that gravity isn't really a force at all, but is the effect of a distortion or bending of space itself caused by the presence of a mass. So Newton's law tells us mathematically how masses attract each other, and Einstein's theory attempts to explain why they do so. I hope you can now see the difference. I'll now elaborate on what I said a couple of minutes ago, that a theory, strictly speaking, can never be proved. By the strictest definition, the concept of proof exists only in mathematics. In maths, a proof is a logical demonstration that a conclusion necessarily follows from a set of assumptions. A theorem is a principle which can be proved by reasoning from basic principles. The best known theorem is, of course, Pythagoras' theorem, that states that for any right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. This can be proved to be true. The classical Greeks proved it over 2,000 years ago by assuming certain Euclidean axioms or self-evident statements. In fact, there are hundreds of different ways to prove it, some of which are very simple to follow and others are pretty complex. There's a website somewhere that lists over 300 different proofs. And there's one that's so simple that I was able to do the maths in my head. And there's no doubt about it, it just is true, end of. A mathematical principle which is generally accepted to be true but hasn't been formally proved is called a conjecture. A famous one is Goldbass Conjecture, which states that every even integer can be expressed as a sum of two prime numbers. For relatively small numbers, it can be shown to be true just by trying it for each even number in turn. By using computer algorithms, mathematicians have shown it to be true for every even integer up to some arbitrary gigantic number. But there exists so far no purely logical proof that the conjecture is true for every conceivable even integer. If and when someone ever does discover a proof, the conjecture will be promoted in status and become known as Goldback's theorem, or maybe somebody else's theorem after the person who found the proof. So mathematicians use the concept of proof to distinguish between conjectures and theorems. When a conjecture is proved, it becomes a theorem. But in other sciences, there's no equivalent process. A theory is not promoted to any other status when it's proved, because it never can be proved in the way a mathematical theorem can. Mathematical theorems are proved by a process of pure logic. The same can't be done with scientific theories. All we can say is that a theory has been subjected to rigorous testing and hasn't been disproved. The more rigorous tests a theory passes, the more confident we can be that it's correct. An idea that's proposed as an explanation for a phenomenon is initially called a hypothesis. This is more or less equivalent to the everyday language use of theory. The hypothesis is then tested by means of observations and/or experiments. Given a set of initial conditions, the hypothesis can be used to predict the outcome of each experiment. If the hypothesis is true and we start with these conditions, then such and such should happen. The actual outcome is then compared with the predicted outcome. If it matches, then we can say the hypothesis is likely to be correct. But if it doesn't match, then the hypothesis is wrong and must be rejected. A hypothesis is promoted to the status of a theory when it's sufficiently strongly supported by the evidence of observations or experiments as to become generally accepted as the most likely explanation of a phenomenon. In many cases, after that promotion, the theory is still subjected to ever more rigorous tests. If it continues to pass those tests, then we can be ever more confident that it's almost certainly correct. But almost certainly is the operative phrase. We can subject a theory to more and more tests and accrue more and more evidence that supports it until we can be sure it's correct to a confidence level of 99.79%. But we can never be absolutely 100% certain that no piece of evidence ever will be found in future, which will show some small detail of the theory to be wrong. To cover every possible combinations of conditions would require an infinite number of tests, which is obviously impossible. That's why it isn't possible to absolutely prove a theory correct, because to do so would require testing to infinity. Conversely, though, it's very much possible to prove a theory wrong. All that takes is to find a single piece of evidence that doesn't fit, that can't be explained by the theory. If a theory is wrong, then sooner or later it'll be proved wrong by the discovery of evidence that contradicts it. And when that happens, the theory must be abandoned or at least modified to account for the new evidence. This is in fact part of the definition of a scientific theory. It must be testable, or as scientists say, falsifiable. That is, there must be in principle a way of proving it wrong if it happens to be wrong. There are many misuses of the word theory applied to ideas or assertions that certainly don't meet that criterion, and are therefore not true theories at all. The most obvious are so-called conspiracy theories, such as those involving UFOs, the imaginary faking of the Apollo landings, the death of Princess Diana, etc. By definition, no conspiracy theory is ever falsifiable, because whatever evidence the rational among us present that disproves it, the believers will simply claim that that evidence has been faked as a further part of the conspiracy. The same applies naturally to religion. Some creationists claim that biblical creation is an alternative theory to evolution, but it's no such thing. Any explanation of anything involving God or anything supernatural, whatever that means, is again by definition unfalsifiable, as it depends on the assumption that God performs miracles and isn't bound by the laws of physics. So any such assertion can't possibly be a valid theory in the scientific meaning of the word. Of course, if a theory is conclusively proved to be wrong, then it must be abandoned. One of my intellectual heroes, Richard Dawkins, tells a true story from his days as an undergraduate in the 60s, which illustrates the point. A distinguished Oxford professor of biology had long held on to his own theory about some aspect of cell structure, which I don't pretend to understand because I'm not a biologist, which went against the conventional wisdom. Most people in the field disagreed with his theory, but none had found any evidence that conclusively disproved it. One day, a visiting American researcher gave a presentation to the department in which he presented some newly discovered evidence which finally proved beyond any doubt that the professor's cherished theory was wrong. At the end of the presentation, the professor, in front of his own entire department, shook the visitor's hand and congratulated him, saying, "You've proved that I've been wrong these last 15 years. That admission was met with rapturous applause. That's a fine example of how science is meant to work. If your pet theory is proved to be wrong, then you accept that it's wrong and move on, though some might do so rather more reluctantly than that professor. So we've established that while a theory can be proved wrong, it's impossible to absolutely prove one correct. On the other hand, there are many theories which are so strongly supported by such overwhelming amounts of evidence that they can be considered as close to being proven as it's possible for a theory to be, such that to all extents and purposes, common sense would treat them as facts. As a comparison, think of the instruction that's given to a jury before they retire to consider the verdict. In order to return a verdict of guilty, they must be convinced beyond reasonable doubt that the accused is guilty. Note the wording, beyond reasonable doubt. It's rarely, if ever, possible to be certain beyond any conceivable doubt whatsoever. No matter how overwhelming the evidence is against the accused, it's usually possible to imagine some way in which it might be flawed. And indeed, defense lawyers are paid to do exactly that. But what matters is whether any such doubt is sufficiently realistic as to be worthy of consideration. For example, the most powerful forensic evidence available today is that of DNA analysis. No two people in the world have absolutely identical DNA, except for identical twins. They do by definition. So if a person's DNA is found at a crime scene, there could be no doubt that he was there at some point, or at least the probability of it being wrong is something like 1 in several billion. If the suspect's DNA was found on the murder weapon, then it doesn't absolutely prove that he committed the murder. It only proves that he touched the weapon at some point. It's remotely possible that his DNA could have got onto the weapon by coincidence. For example, if the weapon's a kitchen knife, it's possible that the suspect just happened to pick the knife up in B&Q one day, then decided against buying it and put it back, and then somebody else did buy it and went on to commit the murder with it. But if there's other evidence connecting the suspect to the victim, say he was seen having a violent argument with the victim a few days before, and was then caught on CCTV close to the scene of the murder within minutes of it happening, then the probability of such a coincidence is so minuscule that no sane person would give it any credence. In such a case, the jury would indeed be convinced beyond reasonable doubt. Similarly, there are many scientific theories for which the supporting evidence is so overwhelming that we can apply the same criterion of beyond reasonable doubt and regard those theories as facts to all extents and purposes. To take an extreme example, prior to the 16th century, everyone took it for granted that the Earth was the center of the universe and the sun, moon, and planets revolved around it. After all, in our everyday experience, we don't feel the Earth moving, and there's nothing to suggest that it does, at least not to those with no knowledge of astronomy. When Copernicus first proposed that the planets, including the Earth, orbit the Sun, this was regarded as a theory for which there was no proof. Johannes Kepler later refined the theory and realized that the planet's orbits are elliptical rather than circular, and found that his model explained the observed motions of the planets with great precision. But it was still regarded as a mathematical model for which there was no direct physical evidence. The first direct evidence that the Earth moves was found in 1728, with the discovery of the aberration of starlight, a phenomenon which can only be reasonably explained by assuming that the Earth moves. Another 110 years later, astronomers measured the first stellar parallaxes, the apparent change in position of a nearby star against the background of more distant ones, when observed from opposite sides of the Earth's orbit. As early as the late 17th century, astronomers had realized that if the Earth orbited the Sun, then nearby stars must show parallaxes, and tried to measure them, but the angles were too tiny to be measured by even the best instruments of the time, and it took a century and a half of trying before anyone succeeded. This is a classic example of how a theory is verified. The theory predicts that something should happen, and then observations show that it actually does happen. Today, that the Earth orbits the Sun is regarded as an indisputable fact by any sane person. The orbital motions of the planets have been measured with such accuracy that we can send space probes to the outer planets on journeys lasting years and be certain that the planet will be in precisely the right place at the right time for the probe to meet it. When Voyager 2 flew past Neptune after a journey of 12 years and 3 billion kilometers, its estimated time of closest approach was in error by 3 minutes. By the strictest definition, we should still call heliocentrism a theory, but one which is verified beyond any slightest shred of reasonable doubt. Only a certifiable lunatic could possibly still believe that the Earth is the center of the universe. Amazingly, there are still a few people today who do believe exactly that, for reasons that have nothing to do with science and everything to do with dogmatic religion. I once had a truly brain-imploding online debate with one of them. Dawkins has invented the word theorem, pronounced that way to distinguish it from the mathematical theorem, which he uses to mean a theory which is supported by massive amounts of evidence, accepted by all informed observers, an undisputed fact in the ordinary sense of the word. To take a more sensible example, consider Einstein's two theories of special and general relativity, published in 1905 and 1915, respectively. For the last century, these have been subject to a multitude of ever more rigorous tests, such as flying an incredibly accurate atomic clock aboard an aircraft and comparing it with one on the ground to measure the tiny effect of time dilation, and have passed every test ever applied, with the observed results matching those predicted by the theory to an accuracy of better than 1 part in a billion. To most people, that constitutes beyond reasonable doubt. Very few scientists now dispute the theories. Indeed, the GPS system, in which the positions of the satellites must be tracked with extreme accuracy, takes account of relativistic effects, both special and general. At the speed of satellites in orbit, these effects are minute but measurable. In my own job years ago, I once tested the software for an aircraft landing system that utilized GPS measurements. The algorithms involved a lot of truly horrible maths with a required accuracy of 1 part in 10 to the 11. Now let's return to my main theme, the claim by creationists that evolution is only a theory. Creationists of the young Earth kind, those who insist that the Bible is literally true, claim that the age of the Earth is only a few thousand years, whereas the accepted scientific view is that it's 4.6 billion years. When the rational among us point out the overwhelming evidence in favor of the latter, the creationists' only pathetic defense is to claim that the scientists have got it all wrong, they've misunderstood the evidence. So let's say the ages of rocks are determined by radioactive dating. The underlying physical process, radioactive decay, is so thoroughly understood that it's utilized daily in manufacturing, such as the smoke alarm in your house, and medical procedures, such as radiotherapy to treat tumours. The Voyager probes travelled across the solar system powered by it. The Curiosity rover is right now exploring the surface of Mars powered by it. And the new Perseverance, of course, as of a few days ago. And millions of people routinely entrust their lives to heart pacemakers whose batteries are powered by it. Following on from this, much of the evidence in favour of evolution comes from the fossil record. The ages of fossils are determined by measuring the ages of the rocks in which they're embedded. That's done by radioactive dating, a purely physical and chemical process which is totally independent of biology. In this way, we build up a timeline of evolution, showing beyond doubt that certain creatures existed before other more complex ones. Combining this with huge amounts of evidence observed in living creatures, such as the fact that every species of mammal, from a mouse to an elephant to a bat to a whale to a human, has the exact same configuration of bones in its skeleton, strongly suggesting that they all evolved from a common ancestor. We can say very much so that evolution by natural selection is itself one of those theories which are established beyond reasonable doubt. That is what Dawkins calls a theorem. Creationists are fond of attacking the fossil record and trying to discredit it, as if it's the only evidence that supports evolution. But it isn't at all. Dawkins says that even if there was no such thing as fossils, there'd still be more than enough evidence to establish the theory beyond reasonable doubt. Some creationists, in perhaps the ultimate example of clutching at straws, have even gone a step further and claimed that God has deliberately planted false evidence to test our faith. In other words, the entire universe is a huge practical joke. Their egomaniac God created it 6,000 years ago, but then invested vast amounts of effort in making it look as if it's billions of years old, just to see whether we humans will continue to believe in him when confronted with overwhelming evidence of his non-existence. Some scientists have countered this stupidity by presenting the alternative theory of last Thursdayism, that the universe was created last Thursday, and each of us simply popped into existence just as we are right now, with all our knowledge of history and our memories of our lives up to now falsely implanted in our brains, rather like the androids in Westworld. Think about it, this is no more ridiculous and no less falsifiable. Think back to my analogy of the murder case. It's possible to claim that every scientist in the world has got the evidence all wrong, and the Earth is only 6,000 years old after all, by means of the God deliberately planted false evidence argument or something like it. But such arguments are so ridiculous that no sane person would ever give them a moment's serious consideration. Most modern day Christians and all mainstream churches readily accept evolution and the age of the Earth as facts, while still believing that their God created it all in the first place. One of the most ridiculous arguments I've heard from some creationists and other types of reality deniers is along the lines of, you can't trust scientists because they keep changing their minds. They tell us one thing, then they tell us something else. To put it another way, they're actually claiming that scientists can't be trusted because they're willing to admit when they're wrong. But anyone with the slightest understanding of science knows that that's exactly how it works. Far from being a weakness, that's its strength. While religion is based on the concept of sacred truth, which must never be questioned, science is based on exactly the opposite principle. There's no such thing as a sacred truth. Anything that's regarded as the truth or a fact is regarded as such only as long as it's supported by the evidence. Remember the Oxford professor. Many of the facts which are now accepted as beyond reasonable doubt were very much disputed in the past when less evidence was available. One of the greatest failings of our education system today is the way in which children are taught science, or rather not. In many, probably most schools today, science lessons simply consist of learning a lot of facts, which must be learned parrot fashion to pass the exams. But science isn't just a collection of facts, is it? It's the process by which those facts are established in the first place. Most school children now are taught little or nothing about that process, what we call the scientific method. As Dawkins succinctly puts it, they need to be taught how to think, not taught what to think. I've already pretty well described the scientific method, but I'll summarize it here. When a scientist tries to explain some phenomenon which is observed in nature, he formulates a hypothesis, a tentative explanation or model which he believes can explain the observed facts while not violating any non-scientific laws. He presents his hypothesis to other scientists in the field, either by means of presentations or seminars, or publishing it in a journal, or both. Others then try to verify or disprove the hypothesis by making further observations or performing experiments in which the observed results are compared with those predicted by the hypothesis. If a hypothesis fails to correctly explain the observed data, then it's wrong and must be either rejected or modified. If it passes all the tests to the extent that it becomes regarded as the most likely explanation of the phenomenon, then it's eventually promoted to the status of a theory. Even then, it may well be subjected to further and more stringent tests. For example, as improvements in technology enable measurements to be made with ever greater accuracy. And the more rigorous tests it passes, the higher the confidence level with which the theory can be assumed to be correct. In many, though not all cases, a theory eventually reaches the status of being universally accepted as beyond reasonable doubt. But if at any time any new piece of evidence is found which can't be explained by the accepted theory, then the theory, no matter how well established or indisputable it was thought to be, has to be modified to account for that evidence. That's why scientists sometimes change their minds, because they admit their mistakes and accept it when the theories are proved wrong. A good example is the story of Johannes Kepler, who has been described as the world's first astrophysicist. He lived at a time when science as we know it was only just becoming established. He was a contemporary of Galileo, who could be said to have invented the methods of modern experimental physics. Kepler was one of the first to accept Copernicus's theory that the planets orbit the sun rather than the Earth. Copernicus himself had admitted that there were discrepancies in the observed motions of the planets which his theory couldn't explain. Kepler set out to try to develop a model which could explain them. Kepler had been assistant to Tycho Brahe, who was probably the greatest observational astronomer of the pre-telescope era. And tragically, he died just 7 years before the invention of the telescope. Tycho had compiled the most accurate tables to date of planetary positions, and Kepler inherited all his data after his death. He initially devised a theory to describe the orbits of the planets based on classical Greek geometry, which was frankly silly and had more to do with ancient mysticism than with modern science. But when he tested the theory by comparing its predictions of planetary positions with Tycho's meticulous observations, he found that it didn't work. So in the manner of a true modern scientist, he abandoned it and went back to the drawing board. He eventually realized that the observed motions of the planets could be best explained by assuming that their orbits were not circles but ellipses. By a painstaking process of trial and error, experimenting for each planet in turn with ellipses of different eccentricity, he eventually came up with a model which matched Tycho's observations with great precision. In so doing, he realized that the motions of the planets could be explained by purely mathematical principles, and discovered his famous 3 laws of planetary motion, which were a forerunner of Newton's law of universal gravitation. For a fine example of how a theory is tested by comparing prediction with observation, consider again Einstein's general theory of relativity, published in 1915. One of the predictions of the theory was that light would be affected by gravity and its path bent by passing close to a mass. This effect would only be noticeable in the case of a very big mass such as a star. One of Einstein's earliest supporters, Sir Arthur Eddington, realized that if a star could be observed very close to the sun in the sky, very nearly in line with it, then it would appear to change position with respect to other stars further from the sun, as the path of its light would be slightly bent by the sun's gravity. The only time that stars can be observed close to the sun is, of course, during a total solar eclipse. So in 1919, Eddington travelled to Africa to observe one. During the total phase of the eclipse, he photographed through a telescope the eclipsed sun and the surrounding star field. He later compared the photos with photos of the same star field taken several months earlier when those stars were in the night sky, and found that the stars closest to the sun did indeed appear to have slightly changed position, exactly as Einstein's theory predicted. Sometimes there can be two or more competing theories which attempt to explain the same phenomenon, and which can each be regarded as valid theories because no evidence has yet been found which conclusively disproves one or the other. But yet is the operative word. Sooner or later, some evidence will be found which is consistent with one theory but not with the other. Again, the history of astronomy provides a good example. In the 1920s, when the expansion of the universe was discovered, the theory proposed to explain it was what we now call the Big Bang theory. In this model, the universe had a definite beginning several billion years ago, in which space itself, or more accurately space-time, came into existence in a kind of explosion and has been expanding ever since. It was initially incredibly dense and incredibly hot, but has expanded and cooled to its present state and continues to do so. In 1948, Sir Fred Hoyle proposed an alternative theory called the steady-state theory to explain the observed expansion. It was, in fact, Hoyle who invented the term Big Bang for the theory that he opposed. He intended it to be derogatory, but it came accepted as the standard name because nobody could think of anything better. In this model, the universe had no beginning, but had existed for an infinity of time. New matter was somehow continuously coming into existence, and as new stars and galaxies formed, older ones moved apart. For a while, each theory had its supporters, and it was impossible to say which was correct. That all changed in 1965 with the discovery of the cosmic microwave background, a flux of microwave radiation of a specific wavelength which pervades the whole of space, indicating that the universe has an overall average temperature of just 3 degrees above absolute zero. This was entirely consistent with the Big Bang theory. Indeed, the theory predicted it before it was discovered. If the universe had begun in an immensely hot and dense state and had expanded and cooled ever since, then you'd expect it to still have a certain very low overall temperature to this day, and to be filled with radiation indicative of that temperature. The CMB is nothing less than the remnant of the Big Bang. Incidentally, Penzias and Wilson, who first detected the CMB, weren't actually looking for it to try to verify the Big Bang. They discovered it by accident while investigating something else entirely. That's how things sometimes happen in science. They were, in fact, radio engineers, and they were investigating sources of static, and they discovered that there was a faint hiss at some particular wavelength that seemed to be going from all directions, and they considered all sorts of possible terrestrial sources that they're trying to eliminate, even to the extent of scrubbing pigeon poo out of the antenna in case that was the cause, and eventually concluded that this radiation was coming from the sky and appeared to be coming from all directions. And they had no idea what it was, so they published a paper saying, we've discovered this radio flux at this particular wavelength that seems to be coming from everywhere in the sky. Does anybody know what it is? And then some astronomers realized that that was the background radiation that they'd been searching for. But there was no way the CMB could be explained by the steady state theory. So Hoyle and his supporters had to accept that their theory was wrong. Today, the Big Bang theory is another of those regarded as beyond reasonable doubt. That chap who said it's not called Darwin's fact of evolution demonstrated another aspect of his ignorance. In common with many of his fellow creationists, he clearly doesn't understand the difference between the word evolution itself and the theory of evolution by natural selection. The former refers to the phenomenon which is observed in nature. The latter attempts to explain it. I once read a comment in an internet forum which summed up the difference in a single sentence. Evolution is a fact, natural selection is the theory. In other words, that evolution happens is a fact, which is beyond dispute in the mind of any rational person, because it's been observed to happen. The theory of evolution by natural selection, as proposed by Darwin and since modified by many others, is the theory which attempts to explain the process by which it happens. In case this isn't clear, let me make an equivalent statement about something I described earlier. Gravity is a fact, general relativity is the theory. That gravity exists is a fact deduced from observation, which is absolutely beyond dispute. You experience its effects every time you drop something or walk uphill. Newton discovered the mathematical law which enables us to calculate the gravitational force between any two objects. But Einstein's general theory of relativity is the theory which explains what causes gravity in terms of the curvature of space. Similarly, that evolution happens is a fact deduced from observation. Darwin himself first deduced it by observing the similarities between many species of animals, which suggested that they must be descended from common ancestors. The closer the similarities, the more closely the species were related. During his famous voyage, everything came together in his mind in the Galapagos Islands, where he found that each small island had its own unique set of animal and plant species adapted to the particular environment of that island. For example, there are several species of finches, each found on only one island, which are closely related to each other but have distinct differences. In particular, each species has a distinct shape of beak perfectly adapted to the specific food source that's available on its island. And I've deliberately used this picture of Darwin rather than the one you usually see of him as an old man with a big beard, because he was only in his 30s when he first formulated the theory. Today, there's an overwhelming amount of evidence in favour of evolution. There's the fossil record, which shows quite clearly that more complex organisms came into existence more recently than simpler ones. It shows intermediate forms which don't specifically belong to one or another class of animal, but are part way between. There are even intermediate forms still living, such as the duck-billed platypus, which is part way between a reptile and a mammal. It has hair and suckles its young like a mammal, but lays eggs like a reptile. And among the animals and plants which exist today, there are many ways in which different species share common characteristics, which enable biologists to construct a tree of evolution, showing which species share common ancestors at different times in the past. The more closely related any two species are, the more recently they shared a common ancestor. We can see an analogy in another kind of evolution, that is, change over time, to use the broadest definition of the word, that of human languages. We can see how the English language has evolved on timescales of centuries by studying old literature. Any of us would have no problem in understanding the work of Charles Dickens, but we consider his language distinctly old-fashioned. In fact, if you were shown a passage from a Dickens novel without knowing what it was, you could probably quickly deduce that it was something from the 19th century from the style of the language. That of Shakespeare is considerably more old-fashioned and often quite difficult to follow. Modern editions of his plays have hundreds of footnotes to explain archaic phrases. And the English of Chaucer from 2 centuries earlier still is almost incomprehensible to anyone today, except those who study medieval English. It's said that Shakespeare would have been able to read Chaucer, but would have regarded the language as old-fashioned as we do his. And today, of course, we see our language evolving between one generation and the next. As well as new words being invented for new technology, young people keep inventing new slang terms which catch on and are propagated rapidly due to the internet. If I hear a group of teenagers talking now, I can barely understand the word they're saying. And of course, within this last year, we've seen the invention of strange new phrases like social distancing and support bubble. An even better analogy exists in the islands of the Southwest Pacific. Each island group has its own distinct language, but similarities between the languages show that they're clearly related to each other, and to that of the Maoris of New Zealand. The further apart any two island groups are, the greater are the differences between the languages. And the further they are from New Zealand, the more different the languages are from Maori. This clearly indicates that in the distant past, people from New Zealand set out in boats across the ocean and colonized the closest couple of island groups. Then some of those people later sailed further afield and colonized the next few groups, and so on. This is almost an exact analogy of biological evolution. The more closely related any two languages are, the more recently they diverge from a common ancestor. For an excellent discussion of the evidence, I refer you to Richard Dawkins' book, The Greatest Show on Earth, which is subtitled The Evidence for Evolution. If that isn't enough, evolution has been observed to happen. We normally think of it as happening on timescales of millions of years, but with very short-lived creatures such as insects, evolutionary changes can often occur within the timescales of human history. An example is a species of English moth which changed its camouflage colouring from white with black speckles to the exact opposite over just a few decades, as the silver birch trees which formed its habitat became blackened by man-made pollution during the Industrial Revolution. The Greatest Show on Earth has an entire chapter titled Before Our Very Eyes, devoted to examples of evolutionary changes which have been observed during human timescales. The American biologist Richard Lenski conducted a famous experiment involving a species of bacteria that ran for over 30 years, corresponding to over 50,000 generations of bacterial reproduction. Distinct evolutionary changes were observed to take place. Returning now to the theory of evolution by natural selection, remember what I said about a theory having to be falsifiable, and that any explanation involving God clearly isn't. Many creationists have tried to turn the tables by claiming that the theory of evolution is itself not falsifiable and therefore not a valid theory. They claim that there's no imaginable evidence that could prove it wrong. But of course there is. Think again about the fossil record and remember that the ages of rock strata are determined by radioactive dating, a purely physical and chemical process which is independent of evolution or biology. If any fossil were ever to be found in the wrong stratum, one corresponding to a time long before that organism is known to have existed, then that would blow the entire theory out of the water, wouldn't it? But no such anomaly has ever been found, so the theory survives scrutiny. Finally, many creationists are fond of claiming that evolution is a belief system which is no more or less valid than their own. They claim that belief in evolution is itself something akin to a religion due to arguments such as the one that it can't be falsified. Needless to say, this is utter rubbish. The prominent American creationist Ray Banana Man Comfort, whom even most of his fellow Christians regard as a loony and an embarrassment, once made a video in which he went around a university campus asking students the somewhat loaded question, do you believe in evolution? Naturally, whatever percentage answered no was ammunition to his cause, but in his own mind, so was the remainder. For each student who answered yes, he triumphantly crowed, there you see, evolution's a belief just as creationism is. Anyone who answers that question with a simple yes is either being lazy and not bothering to think about how to answer it properly, or else is showing their own lack of comprehension of the scientific method. Of course, a scientific theory is not something that you either believe in or don't, in the sense in which religious people believe in God, because science isn't based on belief, it's based on evidence. A theory is held to be true only as long as it continues to be supported by the evidence. So in case you're ever asked that same question by a creationist, here's how I would answer it. Do I believe in evolution? No. I believe that the theory of evolution by natural selection is correct to a confidence level of 99.9 recurring percent because it's so strongly supported by such overwhelming amounts of evidence that it can be considered proven beyond all reasonable doubt. Thank you.
All right, thank you for that, Neil. Anybody have
Thanks, Neil. That's really good.
any questions? What inspired you to do the talk on the subject of theories in the first place?
That's a good question.
Or more of a, what prompted you to do a non-astronomical talk with some astronomical elements to astronomy societies?
Well, why I decided to do a talk on it was, just because I thought it might be an interesting topic. I think what prompted me, well, it's actually based on one of the essays on my website. There's a section on my website called Muddled Misconceptions, and this is one of the pages of it, this subject, which covers pretty much the same as I've just talked about. And another one is the misconception of there's no gravity in space. In a whole section on things like that. So this, what inspired me to write the section on the website was arguments with people like that guy I mentioned, who belligerently insisted it's not called Darwin's fact of evolution, and trying to explain what a theory means to people like that, and then having written it on the website, it just occurred to me that it might make a good talk.
I think in my experience of discussions with such people is it's irresistible force meets immovable object.
Pretty much, yeah. That's about it.
As a biologist, formerly, I can relate one more thing that happened with the peppered moth on birch bark blackened by airborne soot pollution that happened in the Industrial Revolution, which is that since the Clean Air Acts were passed in the, late 50s, early 60s, and the removal of coal burning as a major source of energy from cities, the moths have been observed with the selection pressure of the blackening of the bark removed to have reverted to the normal white phenotype.
I didn't realise that.
It has happened, and I think what has impressed biologists was the speed with which the reversion to the true type took place.
That's a matter of decades.
Yes, rather than 100 years, rather than 100. Yeah.
As was the original change during the Industrial Revolution.
Well, the reversion has actually happened a lot quicker than the original change to the black form.
Yeah, I wasn't aware of that. Thanks for that. I'll to remember that. That trying to explain that, was a great example of trying to get such things through to creationists. I actually tried to explain that example to that same guy who said it's not Darwin's fact of evolution. And I tried to explain that to him as an example. I said, that evolution happens is a fact because it's been observed to happen. And I used that as an example, tried to explain it to him. And he goes, Eddie, it was like banging my head on a brick wall. He stubbornly refused to accept anything I was saying. I'm not sure if he was totally thick and really couldn't understand the word I was saying, or if he just stubbornly refused to understand the word. He was saying, "Are you telling me that a moth suddenly decided I'm going to change colour?" Well, obviously that wasn't what I was saying, but that was the way the argument went. I just gave up in the end.
Well, you're up against prejudice. There's no logical counteraction to it.
Exactly.
There is another example in behavior. During my lifetime, I have observed that the behavior of hedgehogs in roads has changed. When I was a child and you approached a hedgehog on the road in a motor car, their reaction was almost always to roll up into a ball and stay still.
Yeah.
Nowadays, you see a hedgehog in the road when you're approaching it with a car, and the normal reaction of the hedgehog is to keep going.
Yeah.
Because of the selection pressure, the ones that stop on the road get hit and killed.
Yeah, quite.
Howard, I think you had
tell
your
you
hand
a
up.
story actually about many years ago. My brother was driving on a country road in Yorkshire. Wasn't that far from Scarborough, I don't think. He's driving on a country road late at night, and he saw a hedgehog in the road, and he swerved to avoid it, and there happened to be a police car behind him. So he swerved across the other side of the road to avoid this hedgehog, and the police car just kept going. And then the policeman then pulled him up and asked him why. You know, it was like 11 o'clock at night, so he probably thought he'd been drinking or something, which he hadn't. And the policeman said, "Oh, I just saw you swerve over to the other side of the road." And my brother looked along the road and said, "Yes, I swerved to avoid a hedgehog, the one you've just killed."
I was going to say that I remember learning about the moth being selected by the bark type as a biology student at school. And I think an interesting thing, coming back to something you said in your talk, I did the Nuffield syllabus in biology, which was more centered on experiment and finding out for yourself, and you know, learning about scientific method and statistical methods, rather than just regurgitating facts. I don't know whether this is like that these days. I suspect not.
You kind of froze at the end there, Howard, but I'm not sure currently how they do it. Eris isn't old enough to really be doing science. Although they do cover it, but the very basics.
I mean, another example of evolution, of course, which is highly relevant, is viral evolution, which is going on before your eyes. We're putting selection pressure on the virus to evade the vaccines. I was thinking today, we're also probably putting selection pressure on it to evade lateral flow tests. Because if you can evade a lateral flow test, you can pass on. If you can't, you're going to get isolated, and your chain of transmission is going to stop.
And similarly, bacteria are evolving to resist antibiotics.
But be that as it may, one of the things I have noticed, talking about the Kent variant, is that it probably got picked up in Kent in the UK because our supervision of what was going on with the virus is probably better than most countries. What they have found is that similar variants have occurred at fairly similar times in various different parts of the world. They're seeing the same mutations taking place that have, as is unusual for any mutation, it's only the rarest ones that are capable of surviving or flourishing.
Yes, I think they call that convergent evolution, don't they? When you've got the same thing happening in different places, going towards the same endpoint.
Neil, thank you again.
Thanks, Neil.
Waiting, mate.
Yeah, cheers, Neil. Good talk.
Unless anybody's got anything else, I propose we'll call it there.
Just a little thing. Anybody who does any solar observing, it's there's a few interesting things to see last few days. We do have a solar scope, so that would be a nice thing if we can use that as a group sometime.
Mm. Oh yes, Neil, if you want to do a plug, I'm fine with that.
Well, but some of you will know from last time, but this is my book, my science fiction novel, which has got some good reviews. If you look it up on goodreads.com, you can read several 5-star reviews. Paul Money paid me the ultimate accolade. He said it's up there with Sir Arthur and Asimov. So if anybody's interested, details of how to buy a copy are on my website.
Is it on Audible yet?
Sorry?
Have you got it on Audible yet? Because I that's where I'm listening to most of my books on at the minute. I'm getting through quite a few good ones. So you need to get it on Audible.
You can get it electronically for Kindle through Amazon. If you search for it on Amazon, it's a mere $3.99 for Kindle, $7.99 for print copies.
I did order a print copy, but I will admit I've not had a chance to sit down and even start it yet. I'm starting a new job at work, new role at work. So,
lucky you.
But it's got to, assuming it happens, it's going with me to Starfest. So that's about the only time I get a chance to read anything, to be honest.
I know the feeling.
Right. So good turnout tonight, and thank you to Neil again. And
you're welcome.
Right. Good night, everybody. And
Thank you.
I'll see you all next month if I don't speak to you before.
Okay.
Night all.
Bye, everyone.
Thanks.
Bye.
Bye.